Hey guys, so last video we looked at graphing and here we just found an approximate value. If you guys use your table values in your calculator, it'll probably give you an exact answer. But in this example, I just used my graph that I drew by hand, so that's why I kind of said that x was approximately equal to 0.25. And so now what we're going to do is we're going to solve it algebraically, and hopefully this will give us a more exact answer, or at least we can be more certain that x is in fact 0.25, okay? So hopefully we should be good with solving, both algebraically and graphically, but I'm going to go through the whole process with you ladies there. So what we're going to do is, here we have x over x minus 1 minus 2x is equal to x plus 1 over 2x minus 2. My first step here is I'm going to factor the denominators so that way, that way I can see what our LCD will be. So here we have x over x minus 1 is as fully simplified as it gets. So subtract 2x is equal to x plus 1 over, here we can take out that common factor of 2 times x minus 1. And so from here, we should be able to see that we have a common, or I guess our LCD is equal to 2 times x minus 1. So here we only have two denominators. Our first one here is x minus 1, and that's actually in common with our third fraction there, or I guess our third term there. And the only difference there is that this one has a multiple of 2, this one doesn't. So this is how we can kind of see that our LCD here is 2 times x minus 1. If you guys can't see that right away, you guys should know that hopefully that if you multiply a common denominator would be multiplying the two denominators together, and then that could be a common denominator that you guys could multiply by. But if you multiply by the LCD, it'll save you a ton of work, and it'll give you some nicer values to work with, okay? So following those steps that I gave you, here we're going to multiply by our LCD. So here we have x over x minus 1. We're going to just multiply, so we're not going to be multiplying by the top and the bottom. We're going to be multiplying everything by x minus 1, just the numerators there. So we have times it by 2 times x minus 1, subtract 2x times that LCD, which was 2 times x minus 1. That was equal to x plus 1 over 2x minus 2. And that's multiplying with 2 times x minus 1. Okay? And one thing just to also point out is this is equal. So I know that one thing that we also saw was that if we multiply the top and the bottom, we would just be rewriting an equivalent fraction. But to keep this equal, you multiply each term by the exact same thing. So technically this thing is all still the same term. We've just rewritten it. So it's all still equal to one another. But this way we can get rid of those fractions. So what we do from here is we'll start canceling out like terms. So here we have x minus 1 and x minus 1. Here there's no denominator, there's no fraction, so we can't actually cancel anything out. Moving on here, we have x plus 1. That one doesn't have anything to cancel there, but here we have 2 times x minus 1. And if you remember back here, we did simplify 2x minus 2 to 2 times x minus 1. So that means here that these terms here will cancel out. From there, let's rewrite this, let's make this look a little bit cleaner. So we have 2x minus, and that's 2x times 2 times x minus 1. We can do this in a couple different steps, so let's just tackle negative 2x times 2, so it'd be negative 4x times x minus 1. And on our right side, we have that is equal to 1, or x plus 1. From there, we can clean it up some more. Let's distribute this negative 4x inside those brackets. So we have 2x. Negative 4x times x is negative 4x squared. Negative 4x times negative 1, that's positive 4x. That is equal to x plus 1. So now I'm going to, we'll quickly reorder it, and then what I'm going to do is after that we'll move everything to one side. If you want to do this all in one step, absolutely fine. If not, I'm going to show you this in a couple different steps. Alright, so first we're going to combine like terms, and I'm going to also reorder this at the same time. So we have negative 4x squared, and 2x plus 4x is 6x, is equal to x plus 1. Then I'm going to move everything over to one side, so we're going to subtract x and subtract 1. So we have negative 4x squared. 6x minus x is 5x minus 1, and because we subtracted, this will become 0. I'm going to continue writing this up here. So what we're going to do from here is we are going to use decomposition to, I guess, to solve for x. So here, if you guys, do you guys remember what decomposition is? So here we're looking at, it's basically factoring except that the fact that this a value here is not 1. So what we do is we write this middle term here. We're just going to rewrite it. It's still going to mean the same thing, but we're just going to rewrite it so we can pull out some common factors. And so what we can do is let's rewrite this as negative 4x squared. And let's make this into something we can pull out anything in common. So let's break this up into plus 4x plus x minus 1. So here, if you guys notice, 4x plus x is equal to 5x. So it's still the same function, I just rewrote it. Then we'll take out a common factor in our first group. So here we can take out, let's say, take out a negative 4x. So we have negative 4x, and we're left with x minus 1. Then in our second group, we'll just take out a positive 1, so we have x minus 1, and that is equal to 0. Continuing on, so just this is pretty much the same thing as factoring. We'll pull out that common factor. Notice how these brackets here are the same. That's how you know you either decomposed or if you factored right. So we have x minus 1, and what we're left with is negative 4x plus 1. Then we're going to set each of those factors equal to 0. So x minus 1 is equal to 0, and negative 4x plus 1 is equal to 0. In our first one here, we have x is equal to 1, and in our second one we have negative 4x is equal to negative 1, and then so x is equal to 1/4. Now what you need to do here is verify it. The first one, does this meet your restrictions? And if you guys remember, your restrictions are your non-permissible values, and I'm just going to scroll up here for a second. So that is when your denominator is equal to 0. So looking at this term here, and we're actually be looking at both the exact same term here. So if you remember, we kind of already talked about this in graphing, but so what you guys would do is you'd set each of these equal to 0, and what you'd find that x cannot equal 1. Okay? So this actually does not meet our restrictions, so x equals to 1 is not a solution. So what we're left with is x is equal to 1/4. And then just to finish that off, what we do need to do is we need to verify it. And to verify, you plug x is equal to 1/4 into your original equation. And remember, it's not the one that you've manipulated in case you made some errors. So you always put it back into your original one to make sure everything is basically crystal clear there. Okay, I'm just going to move on down. I'm going to start writing into number 2 here. But you guys hopefully should have some room. If not, just write on some scrap paper there. So let's verify that x equals 1/4 is in fact true. So from there we'll have 1/4. So plug in wherever you see x, you're going to plug in 1/4. Divide that by 1/4 minus 1 minus 2 times 1/4, and that is equal to 1/4 plus 1 over 2 times 1/4 minus 2. So first steps, I'm going to simplify the numerators and denominators where I can. So for now we'll leave 1/4 as it is. So divide that by, and 1/4 minus 1, that is negative 3/4. Negative 2 times 1/4, that is negative, and if you guys want to, you guys can leave it as a denominator of 4. So we can have negative 2 over 4. That is equal to, so 1/4 plus 1, that'd be 5 over 4 over 2 times 1/4 is 2 over 4 minus 2. Moving on from here, if you want to, we can simplify the denominator first before we move on. So we have 1/4, divide that by negative 3/4, subtract subtract 2 over 4 is equal to 5 over 4, divide that by 2 over 4, subtract 2, and that there is equal to negative 6 over 4. So if you guys want to, so 2, that'd be 8 over 4. So 2 minus 8 is negative 6 over 4. So if you guys want to, you guys could reduce, but what we're going to do is, you see that we have some adding, subtracting here. So if we leave them as the same denominator, it kind of helps, so that way we don't have to rechange them again. Although I guess when we do start simplifying, it's not going to work out anyways, but either way it's fine. If you guys reduce before or if you do that after, it's absolutely fine. So from here, we're going to use our division of fractions. We have that principle where you flip the second fraction and multiply it instead. So we have 1/4 times that by negative 4 over 3, subtract 2 over 4 is equal to, we have 5 over 4, flip that fraction, so it'd be negative 4 over 6, and we're going to be multiplying that instead. From there, we're going to simplify, so the 4's cancel out there, so we have negative 1/3, subtract 2 over 4 is equal to, here our 4 cancels out again, so we have negative 5 over 6. So now what we're going to do is we're going to simplify our left side. Remember, we don't want to be moving across the equation. We don't want to be manipulating it in any way, so let's try and see if we can make negative 1/3 subtract 2 over 4. Let's see if that equals negative 5 over 6. And if you guys want to, you guys can change this into a decimal, put that into your calculator, or if you guys want to, change it into negative 5 over 6. So we're going to use, I'm going to first simplify 4. So that is equal to negative 1/2 is equal to negative 5 over 6. Then changing that into a common denominator of 6, we have negative 2 over 6, subtract 3 over 6 is equal to negative 5 over 6. And then when you subtract these two, we have negative 5 over 6 is equal to negative 5 over 6. And so that is obviously correct, okay? So there's a little bit more work, I guess, depending on which method you choose. Algebraically, you get a more accurate answer, although it can mean that you have more work to do. So it's up to you guys which method you guys choose to use. So yeah, so comparing the methods, with graphing, if you don't have it in your table of values, estimating it could be very, it's not exact, so it's not always the best method to use that way. Although when we have our graphing calculators, it saves us so much work, and as you can see, it goes by so much quicker. But always to double check, algebraically, it is more of a process, and it requires more steps, but you get a more exact answer. So it's up to you guys which methods you guys choose to use from here on out. Just make sure that if I ever ask you to solve an equation a certain way, make sure you do it that way, but there will be some questions where I give you the option, okay? So for the next question, I'm obviously going to do this in video number 3, and I'm going to go through the few different solutions or the methods that you can choose to solve, and so you guys will just fast forward to whichever method you choose, or if you want to watch the whole video, that's fine. I will go through both methods of graphing, just using my graphing calculator, and I will go through solving algebraically. So the next example just asks you to choose a method, and so you guys can just check your solutions with the video, but I do encourage you guys to try it out on your own first, then watch the video, okay?